And let's see here, I gotta close that off. Save. All right. Line FG passes through 2 points, 0, 2, and 3, 2. Line F prime G prime is formed by dilating line FG by a factor of 2 about the origin. Which statement is true? All right, so we should draw the line. So let's make a quick sketch. So 0, 2 is there and 3, 2 is there. So it's a horizontal line. And then I'm sorry, it's just a line segment. Sorry, I didn't realize what they were saying there. It's a line segment. And now when you dilate it to, you think of there being like these arrows. So, but the dilation of 2 basically means you multiply everything by 2. So you multiply each of these values by 2. So could you give me the new coordinates of it, please?
All right. So you multiply by 2, you said?
Multiply by 2. Yeah. What are the new coordinates?
All right. So if you multiply 0, that's 0.
Okay.
4. So 0, 4. And then it would be 6, 4.
And so that, that gets you here, and look at that. What can you say about those two segments?
Parallel.
Parallel. There you go.
And I was sorry if you hear me eating. I just got Subway.
All
I didn't
right.
realize how late it was. I was like, oh, I got tutoring. So
Yeah, no, I unfortunately have not done a good job lately of getting food. But yeah, I understand. You got to eat. You got to keep the fuel going in the body.
yeah.
So, here we go.
Woke up at like 1, so I was like, I didn't have breakfast.
This is the summer schedule. All right, so dilate line F by a scale factor of 1/2 with the center of dilation at the origin to create line F prime. Okay, so again, like what you want to do here is label the 2 given points. So A is 0, 2, B is 2, 0. 1/2 means you cut everything in half. So give me the new ordered pairs. I know you're eating, but maybe you can jump in when
um, let's see. So I'm moving them.
cutting them in half.
Oh, all right. So it'd just be 0, 1,
Mhm.
and then 1, 0.
Yeah. All right. So let me draw that here. Let me scroll down here. So go ahead and figure out the right answer here. And I'm going to pause for 30 seconds to make a phone.
All right.
All right. So what did you come up with here?
I'd say it's the second one.
It is parallel. Yeah. Good. All right. Man, Subway used to have this like 3 for 20 or something ridiculous at one point. And I
3
would
for
just load up
12.
with 3. Yeah, 3 foot longs for $20 a long time ago.
What the heck?
Yeah. And I would just do that on like Saturdays because it was like 3 meals.
Yeah.
All right. So quadrilateral is dilated by a scale factor of, I can't even read that. Can you tell me what that is?
I think that's 2 over 30.
Okay. Centered around 1, 2. So it's right there, right there. So this one's a little bit harder because it's not, you actually need the coordinates relative to that point right there. Now it looks like all of these are asking about BB right here. So 2/3 means it gets closer. 2/3 means it gets closer like that. So it's gonna look something like that when you're done.
Yeah.
So what do you notice about that segment? Is it longer? Is it shorter? What is it?
Looks a little shorter.
Yeah, I would agree. So it's right there, shorter and shorter. So though, does it run through 1, 2?
Yeah.
It does. That's 1, 2.
Oh, wait, no. Sorry.
Okay, so the other one here is be parallel. Like it's parallel there. All right, so actually I gotta do one more thing here. So maybe give this one a try. It's kind of like what we've been doing. I'm gonna be right back, but you are gonna multiply the coordinates by 3 or by the scale factor, and you should be able to maybe answer the question there. I'll be right back.
All right.
Okay, how are we doing on this one?
I got 12.
Yeah, so this length is 4, and when you dilate by 3, 4 times 3 is 12. There's your answer. All right, so let's take a look here at the next one. I think this is the next one. Let's look right to you. Yeah. Endpoints are dilated by a scale factor of 1/2 from center 4, 0. Now this one's different. You got to start at the right place, 0, 0 and 4, 0, and it's dilated a half. So it's a half means a half. So 0, 2 is where that new point is. Sorry, 2, 0. 2, 0 is where that new point is, and you have to decide how that is relative to the other.
All right. Um,
What do you think here? I mean, which one has the right coordinate?
the bottom two.
Yeah. No, I'm sorry. Center 4, 0.
Or wait,
Well, so okay. So like the dilation point is right there, and it's a half. That means it's 2. So yeah. So C is 2, 0, but B is still the same. I don't know why it's doesn't make sense. Okay. I'm sorry. I'm sorry. This is the, that's why this, so you got to start from these points. Okay. So it's, it's like, it's like this. I'll give you the answer. So if you start at -4, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay. And then you dilate from here half. This point moves over to 0, 0.
oh,
Okay, and that's the new point that we're talking about. And so the new one is half, exactly half um, the old one.
so it'd be the first answer.
Yes. No, no. Yes, yes.
All right.
All right, so I guess you sent over some new ones. Is that right? 9 and 10, maybe.
Yeah.
All right, let's take a look here. All right, quadral EFGH was dilated by a scale factor of 2 from the center 1, 0 to form the new one. EFGH. So EFG, oops. EFGH like that. Okay, so that's the original. And it's dilated by a scale factor of 2 from the center 1, 0. So right there. So that like pushes everything out of its new one. So you can see it kind of like it parallel all that.
Yeah.
And then you can actually see here that like there's a line right here that cuts through it. Because it's talking a lot about a segment that passes through the center of dilation. Um, which is true here. It passed through the center of dilation like that.
Yeah.
Any questions? So it's what I'm trying to say here is it's either the first, sorry, passes through the center of the dilation in the pre-image. Is it parallel or is it the same? Because we could need to pass through the center of the image of the dilation of the image.
Um,
Like basically does this continue to pass? Well, that's not drawn right. That should be like that. This one on the left's better. See how it still passes kind of through the center of it.
yeah.
So I'd probably go with that one there.
All right.
Oh, there's more. Okay.
Yeah,
So I
there's a
got the wrong
lot
one.
on this one. It's like 25 questions.
Oh boy.
Wow.
Okay. Let's take a look here. Given triangles MNO and QRS, which statement explains a way to determine if the two figures are similar? Verify corresponding angles are congruent by translation. Verify corresponding angles are congruent by dilation. Verify corresponding sides are congruent by translation, and so on. So, um, so dilations are never congruent. They're only similar.
All right.
Well, hang on, this isn't verified proportional angles that's what they are. I'm sorry. Dilation, the angles are congruent. Sorry, that is true. So the way you prove that two figures are similar is it's typically side, angle, side, side, angle, side, like that.
Yeah.
So verify corresponding angles are congruent by translation. So, okay, sorry. So the sides are never congruent by dilation. That's because they're either getting bigger or smaller. Okay, now, but when you translate them, they are congruent by translation, but that's not similar. So it's got to be the angle, and the angles are congruent by dilation, I guess is probably the best way to go on that.
All right.
All right. So triangle ABC was dilated from the origin by a scale factor of 2 to create triangle A prime B prime C prime. Which statement best explains why the triangles are similar? So dilations preserve the angles, not the side lengths. Like when you dilate a triangle and then it becomes bigger, the sides are never the same, but the angles are. The angles remain congruent.
Yeah.
Is that okay? So which one of these says that it preserves the angles?
Um. Sorry. Um. Oh, the bottom one.
I don't want, yeah. All right, so whenever you're ready, if you want to send over a few more, I'm going to take a short break to be back here in like 2 minutes.
All right. Take your time. All right, so it looks like you got a couple, we got some new problems here in the chat. Try and go back to the last one here. Take a look. How's that subway?
That's not the right question.
It's pretty good.
All right, so I don't know where we left off. The chat's weird. It doesn't like go back to the first message, but here, I think this is it.
Yeah.
So are the quadrilaterals similar? Yeah, they are. Okay. That's the easy part. Similar means like do they look the same? Yeah, they look the same. Okay. So what is it that makes these similar? So you have to kind of look at these two and decide that like you want to just look for the difference between them and see if you can make the distinction. It's basically down here. You can see that.
All right. Would it be the bottom one?
Yeah, it looks pretty good. Yes, let's go with that. All right, so next one here. Triangle JKL is dilated from the origin at a scale factor of 10 to create triangle J prime, K prime, L prime. Select the option that completes the statement. Triangles are blank because their corresponding sides are blank and the corresponding angles are blank. So we know the following. We know that dilations are similarity. Okay, which means we can get rid of the first and the third. Okay. Now, when the sides are changing, like we've drawn a few pictures here, the sides get bigger or smaller. So the sides are definitely not congruent, but the angles are congruent. So which of these two answers would you choose based on that?
The bottom one.
Bottom one, yeah, good. Okay, the triangle LMN is dilated to form triangle CAB. If angle N is congruent to angle B, what other information proves the two triangles are similar? Okay. So probably always a good idea to kind of draw something. And let's see here. So triangle LMN, triangle CAB, and then we say that N is congruent to B. What other information we need to prove that the two triangles are similar by the AA similarity postulate? So that means you need another angle. It means you need another angle, and you have that here.
Let's see. Would it
But which other
be
angle would you like matches up? Is it you got like this one with this one or this top one with this top one? Which one kind of is in here that would suggest that?
L matches with C?
Okay. And that's letter A.
Yeah.
All right. Very good. All right, let's go to the next one here. All right. The figure has been dilated by a scale factor of 4. Which statement explains how translation can be used to prove the figures are similar using the AA similarity postulate? So again, dilations preserve the angles, not the sides. So one of these will say that preserves angles not sides. All right, so the one I'm looking for here is preserves the angles. This one right here. That's what we're looking for here.
All right.
So go with B on that. Okay, let's look at the next one here. So to decide whether the triangles are similar, all the angles have to be the same. So you need to find the missing angle up here, and remember the sum is 180, and the missing angle down here, the sum is 180. I'm gonna step away for 2 minutes, but I'll be right back, and that will help you to answer it. If they are the same, then you'll be able to see which one it is. But I'll be right back.
All right.
Right. What do you think here?
Um.
Did you find the missing angle?
Oh. The first one was 71.
Okay. And what about the other one?
I think the second one was 62. Or
Good. So they are similar because all the angles are the same. All right. So now you got to just
Yeah.
match up the letters. So like A is at 47 and E is at 47. B is at 71. D is at 71.
Oh. So it'd be the bottom two. One of them.
Sure, and then, oh, those are the same? No, yeah, they are the same. Okay, so it's one of the bottom two. So now the next part is kind of this ratio. So X is the side between the 71 and the 62. That goes with the R. And then do these both say W over Z, or are they? So what is
No,
does? So what does W go with? It's between the 47 and the 71. That goes with Z. So then they're solving this for X by multiplying both sides by R. So X equals R times W over Z, like that.
all right. So it's the bottom one?
I believe so. Yeah, that's the way it's looking to me.
All right.
Let's look at the next one here. Okay, measure of angle ABC, that's 53. A measure of angle ECD, ECD is 40. All right, so you've got to find the other angles in these. And so we're talking about the one up here and then the one down there. And again, the sum is 180. The rectangle there, little square, that means it's 90 degrees. So
All
you
right.
gotta you gotta find those missing angles for me, please.
So wouldn't E angle or E just be 53 too?
No, use
No.
the fact that they add up to 180.
All right. Oh, okay. Got it. So the one on the right, both of them would be 70.
Okay.
And then
No. It's 40 plus 90 plus E equals 180.
oh, wait.
So you've got to be able to solve that for E.
Oh, 50.
50. So E is 50. Okay. Now you got to do the same thing on the other triangle to solve for this angle C down here, please.
All right. Uh, 37.
37. So are these angles the same?
No.
No, they're not. Okay, so what that means is they are not similar. So we're down to the last two. Why don't you look at the last two and decide what is the same or different about them?
They look the same except for the end part.
Okay, so but notice it's sides and it's angles.
Yeah.
What have we been dealing with in this problem?
Angles.
Yep. So it must be that one.
Yeah.
All right. All right, so we're up to the next one here. Sorry. I can occasionally do that. We're not even close to getting done with this. I think this is 18.
Yeah.
All right. All right, so triangle WXZ, triangle XYZ, that they're similar. So to show that something is similar, the sides have to be in proportion as well. We hadn't talked much about that, but the sides are in proportion. And So like you have to sort of imagine this triangle on the right here is plopped down like that. So that's 2.5 and that's 5 there. And you can see it overlaps the 90-degree angle. So the ratio needs to be the same. Like is 5 over 10 the same as 5 over 2.5?
No,
No. And how about 5 over 10 equal 5 over 5?
no.
What about these last two, 10 over 5 and 5 over 2.5?
Yeah,
And how about this last one?
no.
So there's your answer. It's the only one that's there.
All right.
Okay, let's go to the next one. All right, so sometimes you gotta redraw the triangles without the overlap here. So you draw the little one, A, X, Y, and then you draw the big one, A, B, C. And so they're telling you that AC is 30 and they want the length of AY. So this ratio means like whatever AY is, and we is you multiply by 5 and then divide by 2. 5 and then divide by 2, 5 and then divide by 2, 5 and then divide by 2. And one of these will equal the 30 here.
All right.
So which one do you multiply by 5, divide by 2, and get 30?
Um, the second one.
All right, so the second one does work. All right, so next one here. Okay, so the way that this works, the number here is not important. What is important is the order of the letters. E to F goes with L to M. So it's like E to F over L to M, that's good. F to G, that goes with M to N. Do you see that, the order of the letters?
Yeah.
So that one is out. Like it's got to be the same order. And then single segments are not going to be congruent, so it must be this one. Let's take a look. It's E to F, the first two letters, over L to M, the first two letters, equals F to G over M to N.
Yeah.
There you have it. So not too bad here. All right, so I don't know if we'll be really close if we can finish all this. So here we go. It says AC equals 2x plus 6 and EC equals 5x minus 9. 2x plus 6 equals 5x minus 9. And you add 9 to both sides. You subtract 2x from both sides. And you get 15 equals 3x. Divide by 3, x equals 5. We don't have a lesson scheduled tomorrow. When is this due?
Let's just do tomorrow, I think.
Okay, so what's gonna happen if we don't get it all done? What's the plan there?
Uh, I'll probably have to finish it up myself or
Okay,
yeah.
so let's see if we can avoid that here. So again, you're kind of looking for the pieces that go along with each of the triangles, C, E, C, D, A, C, B, like that. So like AB's got to go with ED and AC's got to go with EC and C's got to go with, or CB's got to go with CD. So which of those says that there?
Uh, mm, not sure.
All right, well, let's just go with CD over CB equals CE over CA. So I think that's the right one there. Best that I can read. So that's all I've got here. If you want to send over a few more, we'll keep going here, but I'm gonna be right back.
All right. Wow, this is a big one. Oh crap.
All right, we've got a few more here we can do. Let's do the fast ones. I'm gonna do. Look at this one here, 24 here. Which fact is not used to prove that the triangle is similar? So you never use, well, okay, so not used. So a lot of these are used. The sum, the fact that the segments are parallel, that one is used. The angle being congruent to itself, you're definitely using for that. So it comes down to AB is a transversal passing AC and DE. So we are going to use that because it's going to prove that the angles are congruent like that.
All right.
So that takes care of that one. Let's see if we can really quickly get these knocked out here. So this last one here, corresponding sides of similar triangles are in proportion. So what that means is that it looks like these are the right. Nope, that's not it. That was not it. So it means that 3x plus 24 over 3x equals, so 3x, it's this part to this whole up here, equals 51 plus 34 over 51, which is, looks like it's that first one there. Okay.
All right.
And we'll see if we can do the next last one here, which is this. And okay. So last one here, so they're saying that DE is parallel to AC, AE is a transversal, AB is a transversal. That means that these angles, so one of these angle sets are congruent, is what they're trying to say next. So B to D to E, congruent to B to A to C, that's pretty good. Yeah, so see how 3 is an angle? That's good. That's a triangle. That's no good. That's an angle. That's good. That's an angle. That's good. And so now we've got, you'll just have to choose between one of those and see how you do. We are unfortunately out of time.
All right.
It's probably because they're using two angles. Probably AA.
Yeah,
So what's the difference between those?
one's corresponding.
Oh,
And
then
one's
that's what we're
converted.
doing. We're using corresponding. So there you go. There you got it.
All right.
All right, we hit the wall. That was good. So we're gonna go ahead and stop here for today.